Hi, in this video I'm looking at calculating the arc length and perimeter of the two sectors that I've got here. So the arc length is the length along this curvy line. So that distance there, or if we're going to do part B, that distance there. And arc length is given by the rule that L for length is the angle of the sector divided by 360 degrees times by the circumference of a circle, 2 pi r. And then if we want the perimeter, which is the distance around the outside, I've got to have that arc length, plus I've got a radius here, plus a radius here. So our perimeter is going to be that arc length plus 2 lots of the radius. So if we have a look at my first one, theta is the 80 degrees and my r is the 3 centimeters. So if I go and work it out, I've got that my arc length is that theta on 360 degrees multiplied by 2 pi r. So our theta is 80 degrees. We're dividing by 360 degrees, multiplying by 2, multiplying by pi, and multiplying by that radius, which is 3. And if we go and work that out, that gives us an arc length for my first one of 4.19 centimeters. Then to get perimeter, which is that arc length plus 2 lots of the radius, so that means I've got 4.19 plus 2 lots of 3. And if I work that out, that means my first sector has a perimeter of 10.19 centimeters. Moving on to part B, the angle here is 30 centimeters and my radius is 10 centimeters. So my arc length is the angle on 360 degrees times by 2 times pi times my radius. So I have 30 degrees divided by 360 degrees multiplied by 2 times pi times that radius, which is 10. So that's giving me an arc length, if I work that out, of 5.24 centimeters. And then if I work out my perimeter, which is that arc length, plus 2 lots of the radius, that means that my perimeter is going to be this 5.24 plus 2 lots of my radius, which is 10. So the perimeter of my second sector, if I work it out, is 25.24 centimeters. And we are done. So to get the arc length, we use this rule, angle on 360 degrees times 2 pi the radius, and then to get the perimeter, we add that arc length on, and also the 2 radiuses that make up the sector. The important thing to keep remembering is that the angle is always the angle on the inside of the sector. So it's always on the inside. Sometimes for some larger sectors, say something like this, they might say the bit that's being cut out is, say, 40 degrees. That means that to get the actual angle on the inside, which is the theta we want, I've got to do 360 because a full circle is 360 and minus off whatever that outside angle is. So that means that my angle in this case would be 320 degrees. And that would be the theta that I would use in my rule.